So, indicators of aging are many. There are frequent or recurring defects and failures, and increasing incidence of unplanned maintenance, repairs and breakdowns, and signs of degradations. So the plan may be downrated, or it may require its increasing. It may require some increasing stuff that I cannot see beneath the line. But it's next like this. So predictive maintenance has emerged as a critical strategy for mitigating the many risks of failures by using data-driven insights to predict equipment failures and schedule maintenance proactively. As we said earlier, predictive maintenance uses real-time data to predict when equipment is likely to fail. This allows operators to plan maintenance when necessary, as was discussed earlier in NDT 4.0 and also in NDT 5.0. Please go ahead, please. So we have traditional and predictive maintenance. The traditional maintenance in oil refineries is often reactive or time-based, which can result in either unnecessary maintenance or unexpected equipment failures. So predictive maintenance, powered by Internet of Things, artificial intelligence, shift the focus from reactive approaches to more proactive strategies, allowing refineries to monitor equipment health in real time. So key technologies in predictive maintenance involve the use of IoT sensors, AI, and machine learning technologies, including drones and robots for profiling and monitoring of refinery operations. And it has a lot of benefits that accrue to this predictive maintenance strategy. It reduces downtime, it extends equipment's life, it also saves costs for our operators, and those conveying products from them are routinely vandalized by our people. The price of premium motor spirit, which is the PMS, is highly regulated by government, and that is even though of recent this price has been reviewed and has been deregulated, but we're still having some challenges within the downstream and also the midstream sectors industry. Next time, please. So there are a lot of factors that affect the refinery operations in Nigeria, especially why we are having aging refinery assets in the country, but we are just able to limit to these few factors that affects the integrity of our refinery systems. Next slide, please. There are case studies that I want us to look at. Here we have failures investigation of an insect. This is a boiler system. The boiler tubes were observed to have developed severe perforations and punctures on numerous furnace chambers tubes 22 years after commissioning. Next slide. We also have corrosion under insulation. So general view of above storage tank, inner surface of the storage tank, and also the outer surface of the storage tank. This is a case of corrosion under insulations within the refinery environment in Nigeria. Next slide, please. This is a case study of a pipe weld failure of fluid catalytic cracking unit in the refinery systems. Of course, this has been a major turnaround maintenance has not been carried out on this kind of refinery systems. That underscores why we are having this kind of cracks in various welds within this unit in the refinery environment. Next slide, please. So this is a case study of a piping and heat exchanger corrosion in the refinery environment. You can see the pipe on the left-hand side, and also the heat exchanger surface on the right-hand side has also corroded. So these are serious issues of corrosion in the refinery environment that lead to this failure of the equipment. Next slide, please. This is a fire incident. A fire incident took place in the afternoon hours during normal running of a crude distillation unit in a refinery. So the fire was noticed in the pipe rack above the unit, pump bay area adjacent to the technical structure and below the column distillation unit. Next slide, please. This is a rupture, so it also a leakage incident on the refinery pipeline. As you can see, there was a crack, and this crack was not noticed due to lack of inspection and maintenance in the refinery environment, and that led to a rupture. Next slide, please. So this is an incident in the refinery due to lack of proper inspections, and that led to a fire incident in the refinery somewhere in the US. Next slide, please. So the way forward, we are looking at NDT as the way forward to most of these crises or most of these problems in the refinery environment. We have the NDT. We discussed earlier about the common NDT methods and also about the more advanced NDT methods. So I won't say much on this because we have already discussed this much more earlier in the previous presentation. Next slide, please. So this was the implementation of an NDT in a refinery, as we said earlier. Pipes were observed to have some cracks and also some failures. So after the inspection, these cracks were cut off to be repaired. And this was the major repair work that is being done at the refinery lines. Next slide, please. So we also have a case study that involved a major oil refinery that implemented a predictive maintenance program to improve the reliability of its aging infrastructure. The refinery, which has been in operations for over 50 years, was experiencing frequent equipment failures and high maintenance costs. So the refinery installed sensors on critical equipment such as pumps, valves, heat exchangers to monitor the equipment health in such a manner that a lot of improvement were observed in the operations. Next slide, please. We also have the sensor data was analyzed using machine learning algorithm to predict equipment failure before they occur. The refinery was able to reduce equipment downtime by 30%, decrease maintenance costs by 25% within the first year of using this predictive maintenance strategy within the refinery. Next slide, please. Summary. Experience has shown that major factors of refinery inoperability is lack of undertaking a turnaround maintenance by law. When a refinery is built, the refinery is expected to undergo a turnaround maintenance after 2 to 3 years. But in Nigeria, when especially the 4 government refineries, when they were built, initially they were observing this turnaround maintenance. But after some time, they stopped carrying out this turnaround maintenance as at when due. So over time, they started experience continuous, and it came to the point that they can no longer operate due to a lot of improvement. By leveraging advanced NDT technology, data analytics, and machine learning, companies can predict equipment failures before they occur, leading to.
Ladies and gentlemen, it's at this time that I call on Dr. Felix O. Amathi, MNSC, and applause noted. Let's put our hands together as he approaches.
Okay, that's a typographical error. Yeah. So I am engineer Dr. Francis Ogeneluri Amade. I'm particularly elated. I'm very happy because I came just before lunch. I was busy, and the last 3 papers actually had touched extensively on what I will be discussing. So perhaps the operator will just push the slides, and I might just take 5 minutes of our time so we can all close. Also, happily, a lot of PTI people here. I'm proud and happy to tell you that I'm also a product of PTI. She's my lecturer. I remember you. Unfortunately, I don't know John. Maybe he was too young when I was in PTI. So, gentlemen, this our discussion today, sorry, I have to bring my iPad because I think we are having some issues. This presentation is titled Integrity of Surface and Subsurface Pipelines for Crude Oil Transmission, Recent Developments and Future Perspectives. As I mentioned earlier, authors are myself, Olaye, and CC Oko, who unfortunately is not attending this program today. But we've talked about refineries, we've talked about subsea inspection, and then in between those two techniques is a pipeline. We all know that the pipeline is the most efficient and effective way of transporting crude oil products from one point to the other. Yeah? And then when we build these pipelines, of course, in engineering, we design, and then we design maintainability into whatever we produce and design. Now, unfortunately, these pipelines are laid on the surface or issues with corrosion, internal corrosion and external corrosion. Of course, that is where we need to have non-destructive testing, which will enable us to carry out these checks, these tests on these facilities, so that we don't cause damage, but then we also achieve our aim. So at the end of the day, like it was mentioned earlier, we have the conventional techniques, ultrasonic, radiography, NPI, and so on and so forth. And of course, way down, technology has now advanced so much, has pushed us beyond boundaries, and therefore we have Dr. Bello telling us about robotics. I almost forgot his size. He used to be more skinny, and he's still around. I know him from very many years ago. It's Francis, your friend from A+. Are you surprised? I look younger, right? Thank you. So that is it. So what I'm going to mention here, I'm just going to read the conclusion of what I have on my paper. There's no information I've published here. The operator is even giving the wrong settings. The machine will tell you, hey, the machine will tell you, hey, you are going the wrong way. Please come to this side. So, gentlemen, let's not bore you. We will apply robotics. We will apply advanced entity. We will apply inverse with extrapolation, IOX, which is one of the latest techniques for pipeline inspection. But at the end of the day, we just want to achieve maintainability, reliability, safety of our pipelines across the globe. Thank you.
We have as I was saying earlier, we are about to have the last session of the program. So we are going to call our panelists, the panel members to the stage for the last session of the program. Can we have Engineer Frederick? Thank you, sir. Can we give him a round of applause, please? Thank you very much. Yes. Can we have Engineer Jifo Ifezu, the MD and CEO of Kingsnight, please? Thank you very much. Can we have Engineer Michael Adibute Isara? So we have been discussing about assets throughout the conference, and the theme of the conference is the role of NDT in preserving and optimizing critical national assets. And we all know that this national asset cuts across shipping industry, it cut across the aviation industry, it cut across the oil and gas industry, the transportation industry, the defense, as was rightly presented much more earlier in our various presentations, including the refineries and other critical national assets. So, over time, we know we have been experiencing failures of these national assets across the country. Recently, we have been talking about the national grid collapse and so many other challenges the country is facing. And the essence of this conference is to assemble stakeholder industry to discuss about the challenges facing these critical national assets and see how solutions can be profiled in this conference so as to assist the government in ensuring the integrity of critical national assets across Nigeria. So, I will start from my panelists from left, Gabriel Fergane. So, based on your assessment of critical national assets, you have
TDT, MDA, we've been exchanging mails, but we've not met. This is the first time we're meeting, which is a very good. I've been on pipeline integrity, corrosion management, and construction of both pipelines and other facilities in Chevo. So I'll first go into the most important national asset for me within the oil industry, which is the pipeline. I consider the pipeline as the most important. To produce your oil, you take it all the way from the subsurface to the top side, processes. If there's no pipeline for you to take it out, only you will get the subsidy. So it's very, very vital. And in the oil and gas industry, we've always had issue with destruction. So our security of our pipelines to be top on that. However, for an asset integrity standpoint, from the asset integrity point of view, if you look at your design, if your design captures your environment that you're operating in, and the kind of cushion that you'll be able to, corrosion challenges that you experience in that particular environment, you capture to your design. You have your external corrosion protection properly done, which is your coating and your seat. You have the internal corrosion properly captured, which is mainly the fluid flowing through the line, the corrosivity of the fluid, and whatever you need to do to ensure that that fluid stays non-corrosive as it flows through one section of the pipeline to another. If you're able to capture that, you have a very good pipeline and you operate fairly. But on the security side, which I see as the most important, is We always have vandalization. Sometimes